mod z is less than 1. In this case, what we have to do? So when mod z is less than 1, we have f of z is equal to, we wrote f of z as 1 by 2 upon z plus 1 and 1 by 2 upon z minus 3. So we need to expand these both with respect to this mod z less than 1. So if mod z is less than 1, the case first part, see 1 by 2 upon, this I will write as 1 plus z, and here z is less than 1. So no need to change this one. But in this case, z minus 3 is there. Here z should be less than 1, means whatever, we need to write this in 1 by form. So sorry, 1 minus or 1 plus form. So therefore that purpose, now mod z is less than 1 means it is very clear that mod z will be less than 3. Okay, if mod z is less than 3, it is again very clear that z by 3 will be less than 1. Okay, so this z minus 3 which is here, we have to write this as z by 3, because z by 3 is less than 1. So z by 3 minus 1 I will write here, and 3 is taken outside. Okay, so z by 3 is less than 1. So we change this according to that. So this is equal to 1 by 2 into 1 plus z raised to minus 1 plus a 1 by 2, and this 3 becomes 1 by 6 into, here z by 3 minus 1, so we will write it as 1 minus z by 3, and a negative sign is taken outside. Okay, so now this negative and this positive will become negative here, and this 1 minus z by 3, I will take that to the numerator, 1 minus z by 3 to the numerator. And now you expand this using the power series. So you will get that is 1 by 2 into 1 minus z plus z square, etc., etc. And here also accordingly we will expand. Now the case 2. Okay, this we are doing Laurent series. Okay, now Laurent series, and here Taylor series also should be there. Question is expand, obtain Taylor's and Lorentz expansion. That is a question of obtain Taylor's and Lorentz. Now here this question, this part, this is what? Taylor's series. Okay, Taylor's series you will always do inside a circle. Taylor series is always function is inside the circle. Then in that case, means function is analytic inside the circle. Then in that case we do Taylor series. So this what you got is a Taylor's series. And Lorentz series you will most of the time you will find out in the annular region. So only Taylor's series is always inside the circle. Lorentz is outside the circle and in the annular region there. Okay, so the first case, this what you got now is the Taylor's series, required Taylor's series. Okay. And now in the case 2, this is when 1 less than mod z less than 3. This is the case 2. 1 less than mod z less than 3. In this case 1 by z. So directly we can write from here itself. It means 1 by z is less than 1. From where 1 less than z less than 3 means, if I write one more step here, 1 less than mod z is half part of this, 1 less than mod z. 1 less than mod z means 1 by z is less than 1. Okay, 1 by mod z is less than 1 we will write, and then similarly z less than 3, second part we take, z less than 3, mod z less than 3, that means z by 3, mod z by 3 will be less than 1. So correspondingly f of z you need to change. So f of z is equal to 1 by 2 upon 1 plus z we have, plus 1 by 2 upon z minus 3, this is our function. Now this is equal to, we need to write this as, this is equal to 1 by 2 upon 1 by z form we need to write. So I will take z common into 1 by z plus 1. From here z is common, plus here 1 by 2 upon, and here what should come? Z by 3 should come. Okay, so here I will write z by 3, and here minus 1, and here 3. 3 is taken common. So this is equal to 1 by 2 z into 1 plus 1 by z raised to minus 1, and here 1 by 2 and 3 becomes 1 by 6. Like in the previous one, I will take negative common here, so this becomes 1 minus z by 3. Okay, 1 minus z by 3 will take negative common here in this one, so this becomes minus 1 by 6 into 1 minus z by 3 raised to minus 1. Now again, expanding this one using the power series, we are getting the answer. Okay, here 1 plus 1 by z raised to minus 1, you know it is 1 minus 1 by z plus 1 by z square, etc. etc. Okay. And now case 3 is so this is Laurent series, because obviously it is in the annular region, so this is your Laurent series. And now case 3 is mod z is greater than 3, means outside the circle. So mod z is greater than 3 means obviously mod z is greater than 1 also. Okay, because why we are taking this greater than 3 then greater than 1, because we have here 1 plus z and z minus 3. Suppose here was z plus 2 or something, then correspondingly we will change also. Okay, so mod z is greater than means mod z is greater than 1. So if mod z is greater than 1, that means 1 by z, 1 by mod z will be less than 1. And mod z greater than 3, that also means z by 3 is greater than 1. Mod z by 3 is greater than 1 you will get. Okay. Or conversely we can write 3 by z will be less than 1. So these changes you need to make in f of z. Therefore f of z is equal to 1 by 2 upon z plus 1 plus minus plus or minus equals plus no, yeah, plus 1 by 2 upon z minus 3. So change now this one. So 1 by 2 upon, here 1 plus z is there, so we will write that as 1 by z form. So 1 by z, to write 1 by z, take z common, so 1 by z plus 1 plus here 1 by 2, and here we must get 3 by z. 3 by z means z is taken outside here, 1 minus 3 by z. Okay. So now take this to the numerator, so that is 1 by 2 z into 1 plus 1 by z raised to minus 1 plus again 1 by 2 z into 1 minus 3 by z raised to minus 1. Now series expansion, this is equal to 1 by 2 z, this becomes 1 minus 1 by z plus 1 by z square minus 1 by z cube and so on, plus 1 by 2 z into 1 plus 3 by z plus 3 by z square plus etc.